This is Physics for Grade 10. Produced by Tigray Education Bureau. Transmitted by Dimtsi Weyane Tigray National and FM radio satellites and social media. And also FM Maqala 104.4.
Physics for Grade 10. Hello, students. Last time, we have discussed about the concept of electromagnetic induction. That is, about self-inductance, mutual inductance, and how a transformer works. To remind you, self-inductance is the ratio, the magnetic flux times the number of turns of wire to the current. The factors that determine the magnitude of self-inductance and mutual inductance are magnetic flux, number of turns of the coil, current through the coil. That is, high variation of current increases inductance. Mutual inductance is a process that a change in magnetic field due to one coil induces EMF in the other coil. The good application of mutual inductance is the transformer. The main parts of a transformer are the two coils with different number of windings, and the other, the iron core that holds and passes through the center of the two coils. Let's proceed to today's topic, which is more about a transformer and introduction to electronics. The ideal transformer. The actual transformer wastes a certain energy in it. Its energy can be wasted due to heating. There are two ways in which a transformer may heat up. 1. ED current. ED current may be induced in the iron core. ED current, due to induced current, is set up in a piece of metal when there is relative motion between the metal and a magnetic field. 2. The resistance in the windings of the coils themselves could cause heating. However, the wires are made from a low resistance metal such as copper. A well-designed transformer that uses for a job is intended its efficiency to be 100%. This means that almost all the energy fed to the primary coil will emerge as a secondary coil of the transformer. Such a transformer is considered as ideal transformer. An ideal transformer has an energy transfer of 100%. The ideal transformer equation is 1. The output voltage divided by the input voltage is equal to number of turns on the secondary coil divided by number of turns on the primary coil. 2. Number of turns on the secondary coil divided by number of turns on the primary coil is equal to current on the primary divided by current on the secondary. Example. In an ideal transformer, the ratio of turns on the primary to the secondary is 10 to 1. If the voltage of the primary is 1000 volt, what is the voltage on the secondary? I will repeat it once again. In an ideal transformer, the ratio of turns of the primary to the secondary is 10 to 1. If the voltage of the primary is 1000 volt, what is the voltage on the secondary? Given. Ratio of turns is given. That is 10 to 1. Number of turns of the primary divided by number of turns on the secondary is 10. Voltage input is given. That's 1000. The required is identified. Voltage output. Well, once if the required and the given quantities are identified, the solution will be easy. Solution. Voltage output divided by voltage input is equal to number of turns on the secondary divided by number of turns on the primary, which gives voltage output is equal to ratio of number of turns on secondary to primary times voltage input. Simplifying, the output voltage will be 100 volts. The expression of electrical power is given by P is equal to VI, where P is power, V voltage, I current. Power output will be voltage output times current output. Power input will be voltage input times current input. If the transformer is ideal, the output power will be equal to input power because its efficiency is 100%. That is, voltage output times current output is equal to voltage input times current input. Simplifying, it will be voltage output divided by voltage input is equal to current input divided by current output. This will be the third equation of the transformer. Well, now, students, pay attention. Please answer the following questions. 1. What type of transformer has a voltage in its primary smaller than the voltage in its secondary? I hope you have answered the question. The answer is step-up transformer. The second question, express the three equations of a transformer. I hope your answer to be number 1, volt output divided by volt input is equal to number of turns on the secondary divided by number of turns on the primary. Number 2, number of turns on the secondary divided by number of turns on the primary is equal to current in the primary divided by current in secondary. Number 3, voltage output divided by voltage input is equal to current input divided by current output. Before we proceed to the next unit, let's revise the main points. A transformer is an application of mutual inductance. The ideal transformer has efficiency 100%. In a step-down transformer, the number of windings in the secondary is less than the number of windings in the primary. As a result, the output voltage is smaller than the input voltage. The reverse is also true. Students, let's proceed to the next unit, that is Unit 5, Introduction to Electronics. Introduction to Electronics. What is electronics? Electronics is the study and the design of systems that use flow of electrons through components such as diodes, semiconductors, resistors, capacitors, and vacuum tube devices. Vacuum tube devices. Vacuum tube devices function by Terminic emission. Terminic emission is the escape of electrons from heated metal surface. It provides controllable supply of electrons in a vacuum. When a metal is heated up, more electrons become energetic and escape from the metal surface, just like evaporation of water molecules from boiling water. This effect is known as Terminic emission. Terminic diode. The name diode refers to the fact that it has two electrodes, the anode and the cathode. It is used for rectification, that is, to obtain direct current out of alternating current. When cathode is heated enough, electrons boil off from it and are attracted to the anode in the way current flow in the circuit. The flowing electrons are pulled toward the center of the anode and accelerated to a very high speed. Students, for a better understanding, see the demonstrating figure in your textbook on page 157 about Terminic diode. Cathode ray tube. It is a vacuum tube where electrons move through a vacuum at high speed, which are produced by an electron gun. The electron gun is an electrical component that produces a beam of electrons moving through a vacuum at a high speed. The basic element of an electron gun are heater, cathode, grid in the anode. Electrons are produced when the cathode is heated. The next tube is X-ray tube or X-ray machine. It is a vacuum tube device. It is used for medical investigation and treatment. It is used for medical investigation and treatment of some tumors. It is also used to check welds in pipes, to investigate the atomic structure of crystals. In the X-ray tube, electrons are released from the cathode by Terminic Emission and accelerate through the potential difference to hit the anode at extremely high speed. When these fast-moving cathode rays are suddenly stopped, X-rays are produced. Most of the beam energy is released as heater rather than as X-ray. The anode gets very hot. Its heat is minimized by a large block of copper to conduct heat away and other cold liquid to pump the heat. Cathode ray oscilloscope, abbreviated as CRO. This is also a vacuum tube device. Here the beam of electrons produce spot on a fluorescent screen at the end of the tube. Before an electron reaches the screen, it passes between two sets of deflecting plates. The two deflecting plates are 1. Deflecting plates in Y direction, that is up and down, vertical. 2. Deflecting plates in X direction, that is left and right, horizontal deflection. In cathode ray oscilloscope, when small voltage is rapidly varying to examine its connection across Y plate, it is observed on the screen that spot moves quickly up and down. The deflection being proportional to the voltage and a vertical line is visible, which means very low mass of electrons are emitted due to small applied voltage. Application of cathode ray oscilloscope. There are different applications of cathode ray oscilloscope. Application in direct current. It can be used as a voltmeter and will represent the voltage in the source of direct current as stationary spot of light in the screen. It can be calibrated by using known voltage across the Y plate so that the value of the unknown voltage can be measured. There are technical terms related to cathode ray oscilloscope. They are sensitivity, gain control, time base, and sine wave. Let's see sensitivity. Sensitivity is the size of deflection caused by voltage applied across Y plate of the cathode ray oscilloscope. Gain control. It is a knob device adjusting the amount of beam deflection in the cathode ray oscilloscope. The sensitivity can be adjusted using gain control. Line base. It pulls the spot on the screen from left to right at steady rate and repeats its movement. If line base is applied to a signal mode by direct current, the trace changes from a dot to a line. Application in alternating current. I hope you know that the voltage of an alternating current varies between maximum to minimum, that is from positive to negative. If the time base is switched off, the wave will be represented as a vertical line on the screen of the cathode ray oscilloscope. If the line base is switched on it becomes a wave curve whose sketch is called sine wave. The cathode ray oscilloscope tells us the maximum and the effective voltage. Sine wave. It is a mathematical formula that describes a smooth, repetitive oscillations. Students, please see how dot changes to a line in the figure of your textbook on page 160. Or, if possible, use virtual lab of physics and follow its instruction to demonstrate the cathode ray oscilloscope using computer. Let me ask you one question. Tell at least 4 examples of vacuum tube devices. If you say the examples of vacuum tubes are Terminic diode, cathode ray tube, X-ray tube, cathode ray oscilloscope, you are correct. Let's revise the main points of Unit 5, that is, Introduction to Electronics. Electronics is the study of flow of electrons through devices of electronic elements like vacuum tubes, diodes, semiconductors, resistors, and capacitors. The commonly known vacuum tube devices are Terminic diode, cathode ray tube, X-ray machine, cathode ray oscilloscope, and TV picture tubes. The common element in a vacuum tubes is that all have heating cathode. Assignment 1. Prepare your own short note from Unit 5. 2. See the worked examples about the transformer. 3. Answer all questions in Unit 5. Thank you for attentive listening. With this, we come to the end of today's lesson. Bye.